Welcome to a new series of videos focusing on some of the most extreme objects in the universe. The universe is a big place. In terms of scale, our sun is relatively small in comparison to other stars. Several factors influence how large a star can be, including gravity, mass, and radiation produced from fusion within the core. To understand how large a quasi-star is, let's compare its scale to the sun and the largest known star, Quasi. To do that, we'll have to zoom out quite a bit. This is the sun. Its radius can be used to measure other stars, with a nominal solar radius defined as exactly 695,700 kilometers. As we start to zoom out, the scale of the stars becomes apparent, with other stars dwarfing the sun. This is Quasi. It is the largest star we know of that exists today. It is approximately 1,708 times the radius of the sun, yet only 10 times as massive, making it extremely diffuse, meaning that it is extremely difficult to tell where the star begins and ends. Quasi is so huge that you could place up to 5 billion suns inside of it. However, even Quasi is dwarfed by the quasi-star at 10 billion kilometers in diameter. So coming back to the original question, what is a quasi-star? A quasi-star is a theorized type of star that existed back in the very early universe. The reason for why some scientists believe that the quasi-star existed is the existence of supermassive black holes, such as the one at the center of the galaxy called Sagittarius A star, weighing over 4 million times the mass of the sun. The quasi-star is just one hypothesis of how supermassive black holes formed. The very early universe was composed entirely of hydrogen and helium. Stars were made entirely of just these two elements, having no metals within them. These stars are known as population-free stars. The quasi-star would have had a similar composition of just hydrogen and helium, but the distinction between itself and a regular star is that within a quasi-star, the energy is not produced from nuclear fusion, it is produced from a black hole existing within the core of the quasi-star that is slowly accumulating material. Why would such a colossal star contain a black hole at its core? The reason for this is that the protostar that preceded it accumulated so much mass that the outward force of energy produced by nuclear fusion is no longer strong enough to counteract the gravitational forces, producing a supernova. In the case of the quasi-star, the energy of the supernova, which forms the central black hole, is absorbed by the outer layers of the quasi-star, and the outer layers remain intact. The quasi-star would have weighed up to 1,000 solar masses, allowing the central black hole to grow to an enormous size very fast. The quasi-star would have lived for only a short few million years before the central black hole completely devoured it. Today, no such quasi-stars exist, nor is the case with such an extreme object conclusive. However, similar objects may exist in the modern universe. These are known as Thorne-Zwickau objects, which are stars with a neutron star contained inside the core. Several candidate Thorne-Zwickau objects are known, including HV 2112, which exists within the Small Magellanic Cloud. If the quasi-star ever existed, it would have been as bright as a small galaxy, and the observation of one would have been a remarkable sight. Next time, we'll look at quark stars and the line that divides neutron stars and black holes.